we are going to discuss about Ziegler catalyst. What is the meaning of Ziegler catalyst? Ziegler catalyst means it's a composition of trialkyl aluminum and titanium tetrachloride. Combination of these both is going to be called as Ziegler catalyst, which is very important application having in industry. And we are going to discuss about how the complex is going to form. This titanium tetrachloride is going to form a complex with trialkyl aluminum. How this titanium will be here and aluminum with CH2, CH3, CH2, CH, CH2, CH3. Trialkyl aluminum is going to form in this way. This aluminum is going to form a bond. This CH2 is going to form a bond. Why? Because titanium is a metal which can take electrons from the ligand, and aluminum is also going to coordinate. This is complex is going to be called as Ziegler catalyst. It is a composition of trialkyl aluminum and titanium tetrachloride. What is the application of this particular Ziegler catalyst? Very important application in the polymerization reaction. What is the meaning of polymerization? Polymerization means a combination of many monomer units to form a biggest molecule as polymer. Combination of many monomer units to form a biggest molecule is called polymer. Polymerization of olefins to polymers of high molecular weights and stereogenic structures. We will discuss about that one now. For example, if you are looking into ethylene molecule, if ethylene molecules are there, if they are combining, imagine, so I'm taking 3 units here. If these are going to combine, these are going to form a polymer. For this type of polymerization, what is going to be helpful? Ziegler catalyst is going to be helpful. So there is a bond formation between these monomer units and going to form a polymer. So here Ziegler catalyst is going to play Ziegler catalyst. Will promote this reaction to happen, right? And very important thing, if you are looking into example, if you are looking into example, what is the example we are going to take? We are going to take, imagine we are going to take an example, polypropylene. Let's take an example, propylene. CH2, double bond CH2, CH3. This is going to undergo polymerization in, in presence of Ziegler catalyst. So what is going to happen? This will undergo a polymerization for sure. So here, CH2, CH2, this CH3 is going to be here. The same way CH2, CH2 is going to be here. Because the CH3 is not going to be involved in the polymerization reaction. So what is going to happen here? This type of form is going to form, right? And this is going to be called as polypropylene. So this polypropylene will form actually. In this case of Ziegler catalyst, the high density polymer will be formed. And very important, stereo chemistry also will be monitored here. It will form isotactic. That means it will form a molecule like this. All methyl groups will come onto the same plane if you are taking Ziegler catalyst. Very important what it is. That's what we are going to discuss here. It produces a linear polymer. Linear means in same chain without branching and gives a stereoregular, because the methyl group will be there, right? That will be on the same stereocene on same side. That's what I mean. Which are more denser, because if you are taking this one, right? if you are taking this one, if all methyl groups on same side, this is going to be more dense compared to the other thing. This is called as this not only this one methyl groups. If it is coming alternative, right, it will form isotactic and symbiotic. So methyl groups will be on the same side. Isotactic will form actually. Otherwise, it can form symbiotic also. But mostly it will form isotactic. It will give you high density polymers. And to prepare this type of high density polymers in industry, they will use this Ziegler catalyst in a higher quality. And that's what the industrial applications of this Ziegler catalyst. Examples of this one, the polypropylene obtained by this particular Ziegler catalyst extensively used for the preparation of sheets, pipes, synthetic fibers, domestic articles for everyday life. In industry, they use Ziegler catalyst a lot to get to prepare all these things because they want to prepare high density polymers. And moving on to the next application. So we have discussed applications of coordination compounds. Now the last application of coordination compound is going to be softening of water. Now we are going to discuss about the next application, that is called softening of water. Softening of water. This is last application of coordination compounds actually. We have discussed a series of applications. Softening of water. How the complex are going to help us to soften the water. Already we have discussed about the quantitative analysis of the coordination compounds. The same application will come here. For example, water which is going to give us hardness. What are hardness causing salts? Magnesium plus 2 and calcium plus 2. If magnesium plus 2 and calcium plus 2 are causing hardness, if you are removing these ions, obviously we are going to see softening. So EDTA, if you are adding, EDTA will form complex with magnesium or calcium present in the water. So this EDTA will remove calcium and magnesium present in the water, and this water will become soft. So in this way, the softening of water can be understood easily. So how? Again, I am repeating. This is going to be hot water. Why this is going to be hot water? Because they contains magnesium and calcium ions. And if you are adding EDTA, this EDTA is going to form complex with magnesium and calcium ions. Once after forming complexes, that will be removed and that will go out, and your water is soft. This is no more calcium is not free to react with anything else. So we are free from that calcium and magnesium because our EDTA is saving by taking the calcium and magnesium, and it is forming a water soluble salt. This is water soluble. This is not going to react anything more with our bodies. Water soluble. So our water is free from the calcium and magnesium which are reactive, and so it is called as a softening of water. So we have finished applications of coordination compounds with this softening of water concept.